So this month, we're very lucky to have Steve Shook, the Director of Software Engineering and Quality from Ishpi, talking about the results of applying methods for software excellence, the long view. There are not very many organizations that can boast a commitment to software excellence for decades. And Ishpi is one of those organizations. And a lot of the reason why they can do that was because of Steve's efforts. I met Steve in the early 1990s through Personal Software Process, I believe, with Pat. And I knew Steve was one of us. For those of you that are familiar with Team Software Process, when Steve told me that he launched his family. Steve has also been a longtime co-leader of the Software Excellence Alliance, and I'm very excited for this talk. So welcome, Steve, and I will stop sharing so you can take over. Hey, Raphael. Hey, Daryl.
Thank you very much, Julia. Can everyone see my title slide?
Yes.
Yes.
Yep.
All right.
Yep.
Excellent. Thank you very much. Well, thank you for asking me to present today. Again, my name is Steve Shook. I'm the Director of Software Engineering and Quality at Ishpi Information Technologies. And what I'd like to do today is to just first of all set a little bit of context for what I'm going to be, the material that I'm going to be presenting today. I'll present Ishpi, their long-term results, talk a little bit about how we've achieved those results, talk about what mechanisms we've used to improve and some lessons learned from that, and then just reflect a little bit on some long-term perspective. So the organization that I'm going to be discussing is, first of all, an organization that was founded in 1986, Advanced Information Services. I began with the organization in 1990, and this was an organization that was founded by Girish Seshagiri in Illinois to do software development and maintenance. Later on, we moved into software modernization, and in 2014, AIS was acquired by Ishpi Information Technologies. And by the way, you'll hear me mention Ishpi. Ishpi is it's ISHPI. It's a Native American word that means to move forward or to advance or high above, and it very much fits in the spirit of the organization that I'll be discussing. So Ishpi Information Technologies, or Ishpi, is a U.S. federal prime contractor. We do many different functions in support of the U.S. federal government, including IT support services and cybersecurity and many other kinds of work. The organization that I'm specifically going to be talking about is the AIS division. That is the organization that was formerly separate as AIS, but then made part of Ishpi Information Technologies. And the focus there, again, is on software development, maintenance, and modernization. So AIS and then ultimately Ishpi, this organization began its software improvement. I said I was going to say initiative, but it's really been a journey. That began in 1992, and I'm pretty sure it was January of 1992, and I'm pretty sure it might have been January 22nd, 1992. And that journey has led us to follow a set of practices that we call high velocity development. And it's a set of practices that are based on what started as the software capability maturity model that you might be familiar with, and later became the CMMI. And for those of you who may not know, those are a set of practices that characterize the behaviors of the highest performing organizations, and it provides a framework for how one might improve over time. And it's a model that has 5 levels that increase in complexity and capability, and I'll be talking a little bit about that. In the mid-90s, we began a initiative for the personal software process, and this was a technology that was conceived by Watts Humphrey of the Software Engineering Institute, and we were one of the early adopters of this set of practices that really talked about high maturity level 5 behaviors as they would apply to a single individual, a single programmer, a single developer. And then later that evolved into the team software process, which talked about how those same behaviors scale up to teams. And then over time, we incorporated other agile practices in addition to the agile practices that were already part of the team software process. So the bottom line, what have our results been? Well, you can see that in 1998, we did not do very well on meeting our, 1988, we did not do very well in meeting our schedule commitments. This is showing against the x-axis, indicating the start date of different projects that have started during that time period, what percent deviation our schedule was where we were able to complete and deliver the project. So in the 1988 to 1990 is when I started with the organization, to 1992, which is when we started our process improvement effort, our average schedule deviation was about 112%. What that means is if we committed to deliver and complete something in, say, 6 months, what that means is it actually took us over a year to deliver to our customers. After we began our process improvement initiative in 1992, and we adopted the software capability maturity model at that time, we were able to start to make some significant improvements in our ability to pay attention to schedule. And at that time, we were able to deliver within, say, 36% average schedule deviation. In other words, on an average, 36% later than what we had committed. We incorporated personal software process practices after that, and we further improved. And then later, team software process practices, and we further improved. And then we continued to refine that and implement even further agile practices and do things even more incrementally and dynamically. And these days, our average schedule deviation is negative 0.8%. And what that means is, on average, we deliver exactly on time, or perhaps just a very smidge early. And so we're very proud of our track record of being able to deliver on time for our customers. And we do attribute that to our process improvement effort that we undertook and continued to execute over all that time. Another thing that I'll just mention about this graph is that this indicates not only the average performance of multiple software projects that started during those time periods, but also the range of outcomes. And it shows kind of the one standard deviation boundary around that average. And what you can see is that range of performance becomes narrower and narrower and narrower, which means we become more and more predictable. So now not only do we come closer to our commitments, but our deviations around that average also improve significantly. We have similar results around effort deviation. In other words, if we told a customer that we were going to do something in 1,000 hours, what this is saying is that, in the 90s, we were taking almost 100% more, perhaps, 1,700 hours or 1,800 hours to do that work that we committed that we thought it would take 1,000 hours. And you can see a similar set of improvements where we push that down. Now, interesting phenomenon is when we implemented the team software process, our effort jumped a little bit. And part of the team software process is really getting a lot of buy-in from team members and having self-managed teams. Very compatible with what we now know as agile team behavior. And so I think that in the early stages, we didn't initially account for the extra effort that all that interaction and collaboration would take, but that has corrected itself over time. And you can see in the current recent projects that really focus in many degrees on operations and maintenance, our effort estimates have been within about 1% of what we estimated. And what this means is, you know, in the case where we have, for example, a firm fixed price proposal, effort really corresponds to cost. And so what this means is we can be profitable on a firm fixed price proposal. Similarly, we can take a look at our ability to deliver products that are of high quality when we turn them over to the customer for acceptance tests. And right now, you can see that our average defect density, that is defects per every 1,000 lines of source code, are averaging about 0.13 defects for every 1,000 lines of source code. That's a remarkably low number compared to what you see as industry, or perhaps what you might experience on your PC or on your cell phone. And so what we see is that in industry, it's not uncommon to see acceptance test defect densities well in excess of 1 defect per every 1,000 lines of code. And even high maturity organizations tend to hover right around that 1 or 0.8 to 1.2 type of range. And one thing that I would point out is especially all these dots that you see on the x-axis. Each of those is an increment, a project that we delivered to the customer, and it had 0 defects. We turned it over, they did acceptance tests, they tested it as thoroughly as they wanted to, and they come back and they said that they could not find anything. And that's something that we're very, very proud of, and it's something that gives the customer a very positive experience. It's not something that they commonly encounter in the software industry. So what this means that over time, we've been able to use quality as a driver to be able to deliver, not only delivering on time, but also within budget and be profitable. So the question is also, well, how productive is all this? Certainly, you know, wouldn't this all have a lot of overhead? And the answer is that through use of data, we can pay attention to that and we can push those costs down. So what this chart is showing is our average cost of quality, and we began focusing on this starting in 2009. And so what this is showing is on a given project, what are the appraisal costs, what are the failure costs, and what are the prevention costs? Add those all up as a percentage of the total effort that you put into the project. If you only did engineering work, if you never had to test, if you only had to manage and do the engineering work, you would have 0 cost of quality. You wouldn't have to test, you wouldn't have to do any reviews. People would write code and it would be deployed and it would be perfect and right the first time. But in fact, we know that we're human and we can't do that. So we have to do things like personal reviews and peer reviews and different levels of tests, unit tests, system tests, integration tests. And where those tests have failures, now we need to do rework. So we need to rework from those peer reviews or rework from those tests. And then after we do rework from testing, we have to regression test. So all of that we characterize as failure costs. And then there's prevention costs that go into this, this as well. So those comprise of things, for example, retrospectives, stepping back and taking lessons learned and understanding how we can change our practices to replicate the good behaviors and prevent the things that didn't go so well. Things like root cause analysis, things like investing in training or perhaps research and development, maybe even proofs of concept. Those kinds of things go into prevention. So if we look at our cost of quality of all those activities, again, in an ideal world, these would be 0. But what we've been able to do is improve down to an average on our projects of about 27% total cost of quality. If you look at industry data, it's very clear that industry averages are well in excess of 50%. And much of the reason for that has to do with the amount of time that's spent in reworking things that were delivered to the customer and have to be thrown back, rework in test before we even get to that stage. Rework in all these failure activities. And so we put a special emphasis on preventing the failure activities through appraisal activities and some prevention activities. But again, it's important to keep this in balance. If we put too much emphasis on doing long retrospectives and root cause analysis on every little thing, we'll get excellent behavior, maybe excellent schedule performance, maybe excellent defect densities, but our efficiency will go down. And so we need to have high efficiency as well. And so having this low cost of quality really amounts to high efficiency and being able to do things right the first time. And so we've been able to get that result as well. And in the end, what we really pay attention to is what's important to our customer, how they perceive us. And so what we look at when we started this in 1996, we started a review after every increment with our customer. After we deliver a project or a phase or an increment, we ask them for the products and services that we've performed during this period, have we exceeded or have we met, or do we need to improve? And we ask them to look at, have we exceeded or met or need to improve in terms of quality, in terms of value, and in terms of timeliness. And what we see, as you might expect from looking at the earlier charts, is that in the early days, 1996 to 1999, we didn't have very happy customers. If we look at the percentage of projects that exceeded their needs or expectations, it was around 10% in terms of quality. It was around 11% of projects exceeded their needs or expectations in terms of value, and only 5% in terms of timeliness. As we transitioned and continued our process improvement efforts, what you can see is that this steadily improved. And so nowadays, what you can see is almost 90% of our projects exceed needs for quality, 96% exceed needs for value, and in our recent data, all of our recent projects, 100% of our deliveries have exceeded the customer's needs for timeliness. And so this is something that gives us a very clear understanding that what we're doing is value added from the customer point of view. And you can imagine the impact that has on repeat business, on our performance reviews that come from our customer. As a U.S. federal government contractor, we have, as a DoD contractor, there's something called CPARs. And so those are formal contractual feedback from our customers. And you can imagine the results that that kind of performance conveys back to the project team. And then finally, in terms of achievement, 2 awards that we're very, very proud of that are derived from all of this. First of all, the IEEE Computer Society Software Process Achievement Award, and also the what's called the GISLA Award, the Government Information System Leadership Award. These are awards that are recognized value and accomplishment in terms of software process improvement, and also in terms of security for our practices. And so we're very, very proud of these very prestigious awards. In terms of the models that we've used to steer our improvement, I mentioned early on that we started with the software capability model as a guide for how we might go about improving over time. And you can see that as a 5-level model, our performance in terms of the models tracks very well with our performance with the other metrics that are important to the organization, in terms of schedule performance, in terms of cost performance effort, in terms of quality of our delivered products, in terms of efficiency and cost of quality. So as I mentioned, we began our software process improvement effort in 1992. We had our first appraisal, a software CMMI-DEV IPI, and that revealed that we were still level 1. But we certainly realized that we had made a lot of progress improving. By 1999, we had achieved level 3. By the early 2000s, we had achieved level 4, and finally by 2005, we had achieved software CMM level 5. One thing that approach that we took was that it was never in our goals to get a badge in terms of achieving a certain level. What we always focused on was business performance. We used the model as a guide to say what are the best practices that are known to the industry and how is it best to apply those to our particular projects and our organization, and implement those practices in a way that made sense from a business and project and engineering standpoint, and then assess ourselves to determine what weaknesses still remained and what might be important to focus on next. And achieving a certain level was never a goal. That level achievement happened organically. What this does show, however, even after transitioning to the CMMI model, CMMI-DEV, we continued to retain those high maturity practices, even as recently as our most recent appraisal in November 2019. And we continue, many of you may know that the CMMI model has transitioned to CMMI 2.0, and we're implementing those activities even now because they continue to provide valuable and important guidance for us. So those are our results and what we've been able to achieve. So now what I'd like to focus on, how did we do all that? How did we achieve those accomplishments? And as I mentioned, we now use a set of practices that we call internally as high velocity development. So these are a set of practices at the individual level, at the team level, and at the organization level that really form a toolbox of practices that individual teams can draw on and tailor to individual project and customer needs. So for example, we have a process asset library, IPAL as it's called, and it contains things like policies, procedures, standards, templates, guidelines, statistical techniques. It's a whole set of assets that are available for project teams to draw on. We have data that we've accumulated over a long period of time in terms of the sizes of things that we've built and how long in terms of hours they've taken us, and things like productivity rates and defect injection rates and defect removal yields and estimation accuracy capabilities. And so project teams start out are able to draw upon that data and use the most relevant data that's appropriate to a given project to estimate new efforts. We have secure software development lifecycle practices that come from industry. We draw on practices from ISE Squared and OWASP and CWE SANS. One important aspect is that we draw upon our culture. We've been able to sustain our culture for a long period of time and really foster this focus on quality and security and service to our customers, and attention to detail and being process oriented. And this culture is infused and it is part of our toolbox as well. We have training assets that we leverage. We have support from our Software Center of Excellence, which assists and provides support to individual projects through quality assurance oversight and configuration management support, and our software engineering process group and coaching and mentoring and training capabilities. And we have management and oversight support from our program managers and development managers. And we have tools and technologies that include project management tools, ALM tools, CM tools, automated testing tools. So there's a full suite of dimensions that all go into this toolbox that we call high velocity development. So then how do we use those high velocity development practices on individual projects? Well, we do a project launch, and for those of you who are familiar with the team software process, you're familiar with this, where a project team will take an understanding of the project needs and the customer inputs and the project attributes, and they'll tie that together, guided by the launch process and by organization management guidance from within Ishpi, from the program manager, development manager, and executive management, as well as coaching support. And what they'll do is they'll pull from that toolbox and they'll systematically select the elements from the toolbox that make sense for the project. And then they'll systematically tailor those elements to provide the appropriate mechanisms to execute the project. So what that means is that we have mechanisms, you can think of them as factories, that are used to actually execute that project. And they can range from something that's very simple, like a little mini waterfall for maybe a one-person project that just goes through its phases and delivers. Maybe it's like a proof of concept, to something that's more complex, to something that extends to full enterprise level development. And so the appropriate team size then executes that little factory that they created in the launch, all those mechanisms, and they take those inputs that come from the customer, their requirements, their needs, their environment, etc., and they execute that project and they produce deliverables. And so those deliverables, those completed systems and services, come out the back end. But what's important is not only that we complete those services and systems and we deliver them well, but also we have a lot of data. Out of that, we get best-in-class performance capabilities. And we have a ton of project data that comes out of that performance that we capture. So all those practices that small teams, medium teams, large teams, enterprise-sized teams execute, those are all instrumented and they're captured and they're digested and they're fed back into the organization, back into that toolbox with innovations, with those lessons learned, with those process improvements. And that's really the mechanism that we've been able to use over the long run, over 28 years of doing this over and over and over again and feeding those back into the toolbox in order to produce results and capabilities that we're very, very proud of. So I want to take a step back now, over the long view. If we think back to where we were back in 1992 when we started the software process improvement journey, what was our organization doing? We were a small organization of about 10 to 20 people, and what we were building was PC applications. I personally was building applications in C. I was using a PS2 and MS-DOS, not even Microsoft Windows at that time. You compare it to what we're doing now. We're building mission-critical enterprise systems. We're doing cloud development and migration. We're implementing the latest practices like DevOps and DevSecOps. And so you think about over time all the transitions that have happened, all the changes in technology, all the changes in the way software gets done. When we started, we didn't have email. We had, maybe I remember when we got our fax machine. So you think of the transformations that have happened in this industry over these 28 years, and there's so much that are different. There's scores of different projects and project instruments and hundreds of different project teams and radically different technologies. But what's consistent across this arc from 1992 to today is the fact that we've been able to consistently improve our performance. And that performance has been independent of adopting a new technology or a particular team leader or a particular superstar software engineer. we've been able to sustain that independent of all those different factors. So I guess some key perspective that I would bring stepping back is I ran across a letter that our founder, Girish Seshagiri, wrote to Watts Humphrey shortly after our software process improvement effort started in 1992. This letter is a letter from August of 1992. And I remember as a young programmer being astounded when Girish kicked off this software process improvement effort in 1992. He had come back from a conference. I believe he had heard Watts Humphrey speak, and he said, "This is what we need to do. As the president of the organization, this is what we need to do." And he read Watts Humphrey's book. He gave us each copies of Managing the Software Process, and he had all of us read it. And he said, "This is where we're headed. This is where I want to take the organization." And he started a number of key initiatives, and he pushed them down. At that point, they were called committees. Now they've turned into what we now know as our software engineering process group. And he took certain actions, and he gave the organization a push in a direction. And so what has really remained constant over all this time is illustrated by this letter, that top-down leadership of setting a direction for the organization to focus on continuous improvement, incremental improvement, to focus on quality as a driver, preventing needless rework in order to push down costs and become more predictable in terms of schedule, because poor quality work, defective work is inherently unpredictable. You never know how long it's going to take to fix that last defect. And so one of the first things he did was he created a mechanism that we called the process improvement, that he called, Watts Humphrey suggested, as the process improvement proposal mechanism. And this enabled software engineers, developers, and other project team members to suggest improvements to the organizational practices. And we had a repository, what's now IPAL, our Ishpi Process Asset Library. We created that repository, and we began conducting postmortems. Now we call them retrospectives. And we use those to understand lessons learned and actually improve our process asset library. We actually make sure to improve artifacts. The other thing this shows is that he focused very early on training and bringing in experts. He reached out to Watts Humphrey himself, and he invited him to Peoria, Illinois, and said, "Please speak with us. Please show us how to do this. Please explain to us what you think is important, why you think is important, and how we can learn from other teams and from other organizations." He taught us to focus relentlessly on data, and he kept a focus on incremental improvement. And all those elements are in this letter back from 1992. By the way, I didn't paste the draft of this, which was actually printed on a dot matrix printer. So some final thoughts that I could share with you as we step back and look on this history is that software development activities, they exist within an ecosystem. It's not just a single individual and the individual programmer's skills or certification or training. Those are all very important, and they've always been important, and they will always continue to be important. So necessary, but not sufficient. Those individuals' practices exist within the context of a team. And so the practices and the capabilities of the team can positively or negatively affect what individuals are capable of. Similarly, the individual's capabilities taken as a whole comprise the capabilities of the team. Now that team exists within a larger organization, and that's why the software CMM and the CMMI were created. What is the capability of the organization? What are things like having an organization level process asset library, and having things like organization training and focus on integrated software management and so forth and so on. These sort of organizational perspectives, those are all important. All those are translations of the personal software process, the team software process, agile practices, and the software CMM and the CMMI. But I would take that one step further, and that's that the capabilities of the software organization exist within the context of an enterprise. So excellence in software isn't only achieved at one level. They all interact with one another. Just as a superstar software engineer can just really struggle when they're put on a dysfunctional team, and one poor team member can undermine an entire project team. Similarly, we need the support of the enterprise to make software organizations effective. And so what that means is things like excellence in recruiting and human resources and contract and finance and IT support, all these sort of corporate enterprise capabilities, and I say the word capabilities, those are important enablers of software organizations, and it's one of the reasons that we've been able to be successful and that we continue to focus on these efforts. So there's a variety of frameworks, not only the CSP and the TSP, but the CMMI, now CMMI-DEV, CMMI services, there's ISO 9001, there's Six Sigma. All these have focuses on different parts of the organization. And looking at all of this as an ecosystem is, I believe, looking back over these 30 years is an important enabler of the success that we've been able to achieve. I'd like to close by first saying thank you, first of all, to Watts Humphrey, that I miss a great deal, his insight, but he's written so many books, and we still continue to be inspired by him and the work that the Software Engineering Institute has done, and in particular, the SEI's TSP team. I want to thank all of the software team members at formerly AIS and now the Ishpi AIS division. All of those team members, all of those past and present software developers, programmers, software engineers, technical writers, all those team members, architects, project managers, etc. All of those results really belong to them. It's their execution that has delivered for our customers, and it's their collective improvement suggestions that have made this possible for us. And I do want to specifically recognize two of my colleagues, Bharti Pareni, Director of Software Process Improvement, and Prasad Pareni, Director of Software Development. They're great friends of mine, and I treasure working with them on a day-to-day basis. And then finally, Gir Seshagiri, AIS's founder back in 1996. He hired me in 1990. He continues to serve on the board of directors of Ishpi Information Technologies, and he looked up to Watts as his guru, and we look up to Girish as inspiration on a daily basis. And so I just want to express my appreciation to all of these folks that really have made our success possible. Thank you very much for allowing me to present to you this day, and I'd be happy to answer any questions that you might have.
So feel free to unmute if you have questions, or if you don't want to unmute and you want to type them into the chat box, I'll be monitoring that. I guess, Steve, I have a question. You know, what do you do when your customer has lower maturity than you? Has that been an issue? Like, how do you deal with, you know, I know that was a big issue for many organizations that were CMM level 5.
Sure. Well, it doesn't help, that's for sure. On the other hand, I would say it's not a showstopper. A lot depends, what I would say, is on the relationship and the working arrangement between the customer and the software team that's performing the work for them. And there's no doubt that you know, a dysfunctional customer organization can really limit the ability of software teams to deliver as well as we would have. But on the other hand, we found that we've been able to really take advantage of the best practices that we have in order to help to manage that. So when you think about practices such as risk management and communication practices and feedback loops, all of those things have been very, very important. You know, a project that we started even as recently as a year and a half ago. It was not a panacea by any stretch of the imagination. We had some real struggles. And so it's important to remember that even though the results have been results that we're very, very proud of, they're not without struggles and difficulty. But the mechanisms that we have in place, and we say within our family and within our organization, remember what you know. Those best practices give us good mechanisms to manage those difficult customers and to give us the best possible chance of a good outcome.
Questions by anybody else? I've got another question. So I think one of the things that's striking is like to just, you know, can you tell us just a little bit more about all the technological changes, you know, of starting like in C on PCs to whatever you're programming in now? How has what your quality efforts done to help you transition to new development environments, new development approaches, things like that, new languages?
Well, the first thing that I guess I would say is regardless of the deliverable and regardless of the technology, doing things right the first time is a really important concept for us. To really step back and realize that throwing something out there and needing to rework it and rework it and rework it is not necessarily, it is not a good mechanism for good performance, regardless of your technology. Now, there's a time and a place for that. For example, prototyping, rapid prototyping, in order to manage risk, right? You want to iterate and you want to get through and learn as much and as frequently as possible. But when it comes to creating final deliverables, it is important to do the best job you can, no matter if it is writing a one-page technical summary for a customer that is delivered, or whether it's a phase review report, or if it's delivering an enterprise system. It pays to do it right the first time. So that's a technology independent concept that we've applied since 1992, and we've seen the results of that. Now, on the other hand, we can't ignore that, you know, certain practices, when we first started using the personal software process, many of the listeners may be aware that it has a compile phase, and we tracked defects in compile. As technology has progressed, that's no longer a value-added activity for us, and that has fallen by the wayside. On recent projects, you know, for a long time, we have tracked defects found in unit tests. As we move to automated testing and DevOps kinds of practices, even tracking unit test defects separately as separate from the design and development cycle has been challenging, and it's forced us to think about these practices in different ways. And so things like DevOps, things like automated testing have triggered us to revisit, step back, adapt, see what makes sense, see what's efficient for project teams, and to take advantage of that. So the answer is yes, those technological changes have had a marked impact on how we approach quality. But regardless of that, I think it's the same theme throughout, that we want to focus on doing things right the first time when it comes to an individual delivering to the team delivering for system test, and then the team delivering to a customer for acceptance test right the first time.
Okay, so Steve, we have I think we have time for two more questions. So one question that came in through the chat is, can you say a few words about onboarding and integrating new software developers?
Sure. That is one aspect of our practices that has served us very well, is we have developed and tailored a great deal of training over time. You know, back in the early days of adoption of the personal software process and the team software process, we had a great deal of emphasis on training in those practices so that every engineer knew what was expected of their process work as a developer on a team or as a working team member. That has evolved over time into, I would say, highly condensed, just-in-time training and mentoring. And so we've developed a set of checklists and steps that when we bring on a new team member, it focuses on what do they need to know of the organization, what do they need to know about, you know, where they fit into the organization, what do they need to know about how the team behaves and what practices integrating with the team are important, and what do they need to do as individuals in terms of time tracking, in terms of defect tracking, in terms of communication practices. And so we assign a mentor, and there's an individual who's assigned to do just-in-time training and mentoring for that individual based on all those, you know, dozen or 24 different topics. And so we are able to systematically bring on new team members and mentor them. We don't do typically anymore that huge upfront, you know, heads down training.
Right.
We focus much more as a just-in-time.
Okay, we got two more questions here, Steve. Have you tailored TSP, for example, launches, weekly meetings, earned value tracking to support rapid turnaround required for DevOps and DevSecOps?
We absolutely have, and it goes back to one of our the slides that I showed earlier. Maybe it was around 12, 10.
Oh yeah.
This is the slide, and it's absolutely true that we have tailored for these current DevOps, DevSecOps practices, and every team tailors no matter what technologies they're using. Whether they're using DevOps or before they were DevOps, or, you know, back in the 90s when they were waterfall. Tailoring has always been something that's been integrated into our process.
Okay, another question. It said that success in the slides was often defined by shipping a product to spec. In many technological endeavors, one of the goals is to provide a unique innovation that enables a new tech or commercial frontier. In these cases, it can be hard to provide upfront specifications. Has the application of these processes been correlated to that kind of success? So I guess, you know, how does it affect your ability to innovate and actually just, you know, meet what the customer actually needs, not necessarily what they say they want?
Well, I guess what I would, how I would answer that is, yes, regardless of whether we're able to deliver in terms of, you know, only on schedule or only in terms of a certain defect density, it kind of steps back to, are our customers receiving value for the work that we're doing? Are we meeting their needs? And what our customer feedback mechanisms tell us, independent of any specific small metric, is that, and by the way, in addition to answering exceeded or met or need to improve on these three dimensions, we give them an opportunity to write a narrative, to give comments. And those comments and these kind of feedback in terms of value, for example, tell us that that it has been effective in helping us to meet their needs on these kinds of projects as well.
I would also think, and correct me if I'm wrong, but I think your cost of quality also helps you to, you know, because you have the low cost of quality, you have time to innovate and be creative. Would you agree with that statement?
Well, absolutely. You know, I remember in, you know, 1992, 1993, 1994, where there were people, they didn't stay very long at AIS after that, but they really pushed back that, you know, oh, this is going to interfere with my creativity as a designer. And many of us on this call maybe have heard that argument. And actually, it's really the opposite. We give a structure for the general progression of how things should happen and how, as a team, we agree that we're going to measure and progress through the project. But the fact that we're able to prevent defects and do things right the first time frees up so much time to be able to invest in the upfront stages of projects, things like research and development and proofs of concept and innovation, that otherwise we would have just been shortcutting all that and trying to get to the product because we're so busy trying to fix defects.
Okay, last question. Quality and schedule challenges tend to increase with project size. Can you comment on the typical project size or size duration over the last few years?
What I would say is that there's a wide variety of project sizes. These range from one-person projects that have monthly deliverables, monthly sprints, and deliver a work product every month, and that's been continuing over a period of years, to significant modernization projects that have had in the range of 17 people on a project team. And then we also know that we're able to scale this up by combining multiple project teams as well. And those efforts could last for multiple years in order to accomplish a significant milestone like the modernization of a significant enterprise system. So that's the kind of range we'd be talking about.
Okay. So Steve, I want to thank you so much for a wonderful presentation.
Thank you very much. I enjoyed it.